These are in listen-only mode.
Well, good morning, everyone. Welcome to this edition of the EasyPower Thursday webinar series. Our mission is to bring an array of information pertinent to our industry and our customer base. I'm Jim Chastain with the support group here at EasyPower. And the title today, or the subject today, is how to utilize the ArcFlash database to do a PowerFlow analysis. And I need to start with an apology. If you're describing a lengthy set of slides describing how computer software crunches through a stack of linear equations to resolve real and apparent power in a system, you may be a little disappointed. So I will touch on some of that, but my focus for today is meant to be on the value of the connection between the effort and treasure required to develop a database used for ArcFlash system analysis and the extended use of that database, and then ultimately the relative value to both the facility management and the engineering firm involved with the study. So if you bear with me for a few minutes, I believe I can tie this together. Now, as is our want, as we begin today, I'd like to, if you would, request that you participate in a couple poll questions. And they're all relative to the subject. So first, if you would give us a little bit of feedback, I'd appreciate it. How often do you conduct a load flow study yourself? And we'll just take about 5 or 6 seconds to complete this. I appreciate the responses. And about another 5 seconds for this. Thank you. And then secondarily, here's where people responded. Secondarily, where do you start that process? And if you use ArcFlash, then I may be wasting my breath on you today. But that's where we're going to go after I get through this poll. Good. Some real valid feedback, and I appreciate everyone involved in the feedback here. I'm pleasantly surprised that this is going to be, I think, germane to where I'm headed with this discussion. Okay, so make sure I have everybody on the right page. So I title this discussion the Parallax View, and the thread begins somewhere in the well-published reports about industry trends, and I think you'll find this information reflects differently based upon where you stand in relation to the different parties or resources involved. Virtually every level of management in corporate world has to shoulder the burden of doing more with less these days. In fact, the anthem ringing through the halls of corporate America is reduce cost and overhead. Well, if you're an independent service provider, you must maintain a competitive posture, and similar to other segments of the market, we're experiencing mergers and acquisitions, and the results of some very large engineering service providers in virtually every discipline. Well, it's my assertion that EasyPower can be considered a conduit for improving the situation from either of the perspectives when it comes to electrical analysis. In 2006, concerned that the education system in the U.S. and Canada was not producing enough graduating engineers, specifically in the power and energy segment, a consortium of electrical and natural gas providers established a nonprofit organization called Center for Energy Workforce Development. So one of their goals was to motivate, incentivize, and alert the industry to the potential shortfall in the workforce that was projected in part due to the crop of World War II baby boomers who were aging out of the energy, specifically the energy marketplace. One of the first reports that they produced in 2013 indicated that in the key jobs there was potentially 50% of the workforce retiring or either now or in the near future, and at least 2% of the remaining potentially needed to be retrained based upon the technology and the advancements in the industry. So in their 2013 survey, they reported, be used kind of as a mile marker in this effort or a yardstick to assuage some of the apprehension. As a part of this report, specifically talking about engineers, power systems engineers, they indicated that realistically there's only about 15,000 engineers that would be affected by this migration, and the report seemed to suggest that the Hallett Halls of America's engineering colleges had enrollments to cover this amount. Of note here, though, is also there's a significant impact in other fields of technicians and line workers, and that raises other questions, and I'm not really going to kind of touch on that for now. But it does play into this discussion. IEEE got into the same dialogue with their Power and Energy Society Education Committee. In 2015, they released a survey that was conducted in the previous 2 years of the top engineering schools in the U.S. and Canada. This was self-reported data, and it focused specifically on power and energy curriculums and studies. The study includes information on faculty, course curriculum, and research funding in this particular market. While the results did not include projected graduation rates for the future, it did reflect that the currently enrolled students in these fields had doubled over the past 10 years, whereas in 2002 we were seeing only 2,500 students in these fields. It had increased over 5,000 now in 2012. 2012. So there was, and this includes all the different levels of degrees. Now, if we look at the outlook as projected by the U.S. Bureau of Labor Statistics, it seems to boil down to this. There is little, if any, actual increase in the overall demand for the number of power systems engineers. What we see realistically here is about 1%, and this is over the projected next 10 years. But they do notice or note that there is a trend, whereas in the past this category of engineering was primarily employed with corporate America or in corporate facility staff, that there's a trend in the industry to move to outsourcing, and so most of these jobs will be transferring, if you will, to engineering service organizations, both large and small. So it's safe to say at both ends of the spectrum, reducing cost and improving productivity, basically doing more with less resources, is the compass that's going to be directing both types of organizations. Well, so what does this mean to me, you may ask? Well, frankly, to compete, whether you manage a corporate facility or you're a service provider, you will be asked to improve your productivity and basically do more with less resources. To thrive as a consultant, you should be prepared to provide services and support formally provided internally as part of a facility staff. To succeed as a facility manager, you need to be able to efficiently coordinate your resources, and this is where EasyPower comes into the discussion. Well, let's start with productivity. We have documented examples comparing EasyPower against comparable tools showing a clear increase in productivity, and we refer to this or show this as the increase in bandwidth, where we have had projects conducted by independent consultants with multiple tool systems available, and comparing project completion time, both new users on each tools and experienced users on each tools conducting the same project. We realize or see a consistent 30% improvement in productivity or throughput, and so we like to point to the fact that all else being equal, engineering firms could recognize an increase in productivity with their electrical analysis requirements. We likewise suggest to facilities managers that even if they outsource their studies, that they should request the digital file, and that, I guess, is a left-handed way or a backhanded way of suggesting, because of its ease of use, EasyPower is the platform that should be employed for these types of studies. Now, a few weeks back, as a lead in for one of our Tuesday refresher webinars, I asked the audience how often they delivered the EasyPower file, .dez file, along with other results with their ArcFlash reports and study to their client. And frankly, I was surprised by the response. Granted, this is a limited sample, but still germane to the discussion. Less than 30% of the time did the audience provide the digital file to the customer. Well, why was I surprised? Well, for starters, the client paid for the data to be collected and very often contributes to that particular effort in terms of manpower or maintenance staff that has to accompany a survey. The client pays for the model to be built and the data to be analyzed. So I think maybe I'm missing the part of the argument that determines that the file should not belong to the client. Well, Jim, you may ask, the customer doesn't have EasyPower, so why give it to him? Well, for starters, it may be because he doesn't even understand what the file represents. And that may be the soapbox here that I'm kind of climbing up on. So what happens when he gets down the road and somehow learns that the file represents the digital model of his system? Do you think he'll ask for it? Is that, at that juncture, is that the engagement that you want to have with a client that potentially you would value as a partner, or is he going to look at the situation as an adversarial one? My point is this: which scenario is really more productive in the overall scheme of things? If the client doesn't know and he decides somehow or another 5 years down the road when he needs his study updated, that whole process is going to be much easier if the database is available, is he going to feel that you are a partner in the process, or that you have some sort of a restriction to his need to manage a system? And if the goal is to reduce cost, he has to come to you to be able to utilize that file, even whether it's internal or with other consultants for some other reason that you may not be available. On the other hand, if the study report includes the file and you as a consulting firm discuss with the client the advantages of accessing that particular data with some form of the EasyPower tool, and I list here One-Line Designer, but frankly PowerFlow is another module that not only can you make modifications, but you can further refine the file for load flow purposes. does this not benefit the customer and engender a better connection, a more partnership, a more supportive role that you could count? I'm just saying, it seems like there's some advantages in taking that stance. So what's the downside of withholding the file? If you expect to speak to this customer every 5 years, that's probably not much downside to it. But if he does not have the bandwidth or expertise to conduct a study in the first place, what's your real concern? If he's engaging with you basically just on price, then that's one thing. If he's choosing to outsource this function because of the complexity of the task and he doesn't have that capability internally, then I maintain that there's footing there for expanding that relationship, and part of that is educating the customer, the client, to understand the value in the service that you're providing, creating the data file. So what does that insider knowledge really mean? The more the client understands that the significance of the data file gives him better insight into a system, the better you can educate him, the better the chance that I maintain he will seek advice from you in the future. So this is what I mean about expanding the communications with your client. Say, Jim, you're just trying to sell EasyPower tools. Well, how does that help me as the consultant? The overriding fact that underlies this conversation when it comes to EasyPower tools, and we kind of repeat this as we're discussing the tools with anybody, the tools themselves will not make you a power systems engineer. But in fact, they will make it much easier to communicate with a power systems engineer. So in every real sense, we are selling communications or an improvement in communications, because as the studies show, the more and more corporate manufacturing sites will not have the expertise to fully analyze and in many cases troubleshoot, and certainly not expand or design new sections of these plants. So the point that I would make in the systems is that when you're outsourcing the study, if the typical workflow is to create labels, generate reports, and then they sit on the shelf for the information flow stopped at this point. The consulting firm provided data, and it maybe didn't mean much other than the fact that we're in compliance. So if anything, the client gains more insight in the system by depending on his engineering resource, and if that is not fully extended, how can he ask intelligent questions? Is he hamstrung at that point? What I would suggest or promote is that the tools make the difference in this communications, and if the customer has the ability to look at the data files, if the customer has the ability to communicate either his need to expand his system, to troubleshoot his system, to reflect or troubleshoot problems that he's saying, it's that ability to access you as a resource on the same platform that will, I think, generate returns on that investment that the customer made initially with you, and then ultimately you can leverage into an increased or expanded relationship. So this ability to exchange files and duplicate analysis makes for more efficient idea exchange, and I think builds the trust that is going to be necessary for a better partnership. So minor changes can be affected by the facility people, and then engineering resources can be utilized to verify and update compliance with this type of exchange. So this brings me to the discussion about PowerFlow. An ArcFlash database primarily developed to analyze short circuit and ArcFlash is really looking at the worst case event in the form of current surges and faults. And the point is to make sure the system will survive, the protective devices will activate properly, and along the way we're not exposing any unnecessary safety hazards to personnel. A load flow study, on the other hand, calculates system limits during normal operations, and these need to accommodate voltage fluctuations, loading limits, even environmental extremes. So think about this. The database that we've developed for the short-circuit and arc flash is really built on nameplate data. There's no provision for actual loads, and the actual currents or voltages during normal operation in many ways aren't even considered. And so at least I refer to the arc flash database as an ideal model. Perhaps the most accurate part of the model is in terms of the operation of the protective devices, because these are taken straight from the manufacturer's data sheets and have maybe a 5% guard band one way or the other. Virtually everything else is based upon, as I say, the ideal nameplate data on the motor or generator or source. Load flow, on the other hand, is a snapshot of system conditions on a particular operating condition. And as we're doing modifications, we need to consider what those different configurations may be to reflect a true statement or a true picture of the power of the system. So to do this, we need to identify the realistic operating limits for the system. Now, clearly, in industrial facilities, there can be changes in plant loading. There can be issues with power factor correction, or in fact, power factor correction may be already installed, and it really was not a significant part of the arc flash study. Transformer tap settings actually can vary if we're utilizing automatic tap adjustment. Again, that's not necessarily included in arc flash. Peak load, the cogeneration, plant expansion, emergency generators, all of which will vary based upon the configuration or the scenario that we're doing for load flow. Likewise, on the higher voltage side, there can actually be supply and demand issues based upon the season, based upon the growth of the community, based upon the growth of our plant, the ability to kind of add internally and be able to make a decision on whether or not we need to expand or we have the capacity, electrical capacity, to support additional system development, and likewise system losses. So that's what needs to be incorporated as we're converting the file, or improving the model, I guess is more accurate. But the advantages, or the ultimate goal, is to utilize now that improved model to allow us to make assessment or judgments about sizing of transformers, feeders, other capacity issues as we look at our plant. Likewise, if we're bringing systems out of mothballs, there can be updates or changes that weren't reflected when the system was designed. Looking at loss evaluation, power factor correction, whether or not we have the adequate system capacity. And these are all part of a normal maintenance facility engineering routine. I suspect, I'm taking kind of a leap here, but I suspect as this migration of jobs in the engineering field happens from layoffs or outsourcing, there could be a potential for some of this capability, some of this oversight to be missed in the contract side of things. We see already in the industry a development of facility management organizations, and for the most part they operate with a checklist of features and services, and if for some reason, and very often a major part of this list isn't necessarily on that checklist. So I would assert if a client doesn't understand the significance of the ArcFlash database, he may very well not appreciate how it can be used to stay ahead of the maintenance schedule. But Jim, they have this covered all the time because they do an annual thermography scan where they come in and do infrared imaging. Well, folks, infrared imaging and profiling is a good analytical procedure, but the problem can arise that if we happen to be taking images when the load profile or that particular piece of equipment isn't running at capacity or at the level that's one of the configurations would suggest, then the thermal image may not represent a problem in the system, a potential problem in the system that frankly would be revealed in a load flow study. So I would go as far to suggest that by developing a more accurate load flow model, tracking the voltage and current readings against what the model predicts, we should be able to identify the system elements that should receive or should be troubleshot or receive, and one of those tasks would be an IR scan, and thereby minimize the cost of that scanning and make it more effective in the process. So basic PowerFlow problem is to calculate the power drawn by each of the elements in the system as it's proportional to the voltage, and as the voltage changes with the load, the power and the current that's produced by the system is varied, and over time this is an interdependent relationship. Well, this is what computers are good at, is solving in an iterative basis where we incrementally vary all the elements until they converge, and the bottom line, or the direction that we're taking that part of the discussion, is balancing the real power with the apparent power that the system needs in the form of reactive power or reactive impedance, which needs to be overcome as we're producing real work. So again, these are the basic equations that need to be solved. Why can't we just use the NEC load calculations based upon the equipment, because that's what was used to size the cable when the system was originally built. Well, it turns out, and when you find this every time you go to a utility company and explain to them that this is how our facility was sized per the National Electric Code, and we'll receive a nod, and the utility comes back and provides a transformer that's about 60% of what the maximum load that NEC calculations predict, and that reflects the conservative nature of what the NEC standards represent. PowerFlow, on the other hand, generally is based on actual loads, so there's going to be a difference between the guard banded or design maximums versus what the actual system's running at. So that brings us to the steps required to utilize ArcFlow database for load flow. And in short, the process is to run PowerFlow, at least in the EasyPower world, is to take the ArcFlash database and do an initial run on PowerFlow to see what results in terms of bus voltages and branch current. Now, frequently, when we're involved in a ArcFlash study, we actually take the voltage and branch current readings on site when we're assisting in data collection, and then run a PowerFlow as a method of doing verification of the accuracy of the data collection if we have a mismatch between the actual branch currents and the bus voltages from what was taken on site versus what the model produces. That could reflect a either inaccuracy entering the data or a mistake in the data collection process. At any point, once we're at the point of having produced the bus voltage and branch current predictions, we identify the source of discrepancy. They can be on the model side, where we've misentered the data. More often than not, the first place you want to start is at adjusting the actual motor loading, and this can be done on a gross basis where you say, well, on average, our motors run at about 60% of their rating or maximum capacity. The tools allow us to start at that point, and so that would give us this first order approximation. But then, again, because we're doing this on an iterative basis, we would start with the largest discrepancy, identify where the source of discrepancy is, and then even at that point it could be a system malfunction, or it could be just a problem we have in creating the model. At that point we want to make adjustments, whether it's to improve the system or whether it's to improve the model, and then we repeat that process. So this ends up being, and it's worth noting at this point, PowerFlow or load flow, once the study is done, it's very, I guess it's very accurate to say it's a snapshot of the system at a given point in time. And so if we haven't properly modeled or tracked or data logged over time all the different variables that the system is susceptible to, we again will have an inaccurate model. The point is, as the model improves, we would continue to log voltage and current readings, identify fluctuation trends, and if that trend or that fluctuation exceeds a specific delta, that would trigger our maintenance team to troubleshoot or diagnose the cause of that trend outside the limit that we've established. So that's, at a 10,000 foot, that's kind of what the process in a maintenance environment you want the process to entail. So how do you develop more accurate load data? Well, I already mentioned just doing a gross load setting, which the tools allow us to do. There are other intersections with the real system that we can utilize to improve this data, one of which, if the customer or client has a SCADA system where they automatically collect data on certain buses or certain loads, this can be utilized as the basis for running the PowerFlow, because it will reflect the specific loading at the point in time that we've done the reading. And here again, we may want to consider either configuration or an average over some period of time to improve our model. And another way, and again, if we don't have distributed metering as much as we'd like, we may want to install temporary metering or just survey the plant taking portable readings of both bus voltages and current. One system, and if you've ever seen me demonstrate our label capability, we had a customer say, oh, I would like to utilize the QR code that you guys put on the label and allow my electricians, as he approaches the panel, to scan the code, and then on his mobile phone or tablet that has a QR scanner in it, bring up a data sheet or a spreadsheet where he can enter the voltage and current that he's reading on the panel. Again, it's an extremely valuable way to log the data, the time, and at the same time verify that we had a manual inspection of the panel without incurring a lot of additional cost in hardware. And then another way to do this is to have longer-term data logging instrumentation that can be installed on a temporary basis and record cycles as our system goes through its normal operation. Well, what I want to emphasize at this point, at all of these intersections, especially when we're dealing with facilities management that may not necessarily have the engineering expertise as you would expect from an engineering services organization, each of these intersections, to improve the model, if the customer has it and is so motivated, is an opportunity to touch and bring value to the client. At that point, my assertion is that you become a solution provider. It's an opportunity to stand apart from the crowd, and you're not just showing up to bid on projects, as he kind of realizes he has a particular need. Again, to get to this point, it requires some education, and again, that's another point where you can bring value, whether you recognize an immediate return. I think there's a long-term investment that both of you are making when you have those kind of conversations. But along the way, and this is where the emphasis is, by utilizing and improving the database, he's actually reducing or he's spreading out or treating his investment in arc flash study that he can expect to return. And to do this in the future, or as they understand how to do data collection, they can reduce their arc flash by improving the model, verifying that the data is accurate, sending the model to you for update or verification or re-compliance, doing the reports or labels. Again, you are reducing or helping him reduce the cost of his overhead. But then in specific to the load flow benefits, as you assist the client to refine his model, you can help him determine collection data points, help him develop the plan to do the tracking, and then as additional analysis is required or troubleshooting is required, you are more available to step in, albeit even remotely, because now you have the ability to exchange this updated file. And again, the goal, what I believe is happening when this kind of a dialogue is taking place, is that he's more effectively accessing his engineering resources, and you're able to more accurately reflect value and an expanded service level, and helps you stand apart from your competition. So at this point, I want to jump into the PowerFlow tools and cover a real simple example that is worth, I think, discussing basically what's available from the PowerFlow, and it becomes very, I guess in my mind, apparent where the value of this is if we kind of do that. So let's jump into where we are. I need to get rid of my eraser. And then jump into the tools. Now, as much as we brag about how easy this is to do, one of the things that I've found is that maintenance electricians and people that understand electricity don't instantly say, hey, yeah, this makes me a power systems engineer because I can do all this stuff. The consistent feedback I get is that, wow, now that I can see what's going on inside the system, inside the my electrical system, I better understand why I've been following the rules I have all these many years. And I think that's part and parcel of what the tools bring to the party. So here we have a database that was utilized for arc flash, simple as it is. I'm going to go into PowerFlow, and we're going to solve the equations. And what this gives us is the ability to look at a number of items in the system. First of all, as we look at our icons here at the top, I'm going to uncheck these so we can talk individually about each of the display. First of all, it allows us to see what the voltage levels are in each bus. And here we're set in per unit, and we can see we have a slight voltage decline as we go through the system, and this is representing the phase angle of the power. Now the display, if I locate the mouse in the center of the screen and right-click to PowerFlow options, this lets me show or control what's being displayed on my one-line output. If I want to be able to show this in kilovolts, we can do that, and that gives me a better understanding of the voltage levels that were coming through at each bus. Likewise, if I wanted to look at the generator data or the utility data, this is showing me the real power and apparent power that's being supplied to my system. And again, I can control that display. And at this point, we're looking at megawatts and megavars. At some point in time, I may want to look at power factor. If I look at MVA and power factor, we can see with this particular system with the motor online, we have a power factor that's just slightly below 0.95, not necessarily bad, but that's something that this is a good touch point in terms of making sure my client's utilities aren't necessarily high because of him having power factor penalties. Likewise, we can show the motor load data. Here again, we are looking at the power factor. I may want to come back and show my megawatts and megavars at the motor, and we can see that to get the real work, the real power out of this at 3.9 megawatts, the utility company had to supply, at least all the way to the motor, 1.2 megavars, and so there's sufficient, I guess, concern as far as that. Even though I'm not getting a power factor penalty, there's some amount of loss by increasing or having this apparent power have to flow all the way through my system. Again, this is not something a facility manager, even if it were a PE, would necessarily jump on, but it would be sure a good question to go back and ask my the consulting firms, like, hey, should I be worried about this? I can see that I have this much reactive power. All right, we can also look at branch flows. Again, we're looking at real power and apparent power or reactive power. We can look at the voltage drops on each transformer. We can set limits, and this would be the trend line that we were talking about earlier, and we could set controls that if these drops were exceeding a certain value, we could flag, the alert would be sounded. And likewise with losses through any of the branch flows, we can demonstrate that. Now, a case in point is that of a power factor correction. And so if I look at my branch flows, I can see here I've got a reactive power 2 mega MVAR, and that's something that needs to be potentially could be accommodated if I utilize power factor correction somewhere near the load. So let's go back and do this. Basically, I have to supply something in excess of 1 megavar. So we're going to go back to database edit. Let's go ahead and put a capacitor on there. What would happen to the rest of our system if we put a capacitor of this ilk or size? Let's go ahead and switch it on and off. Go into the database, make it a 1 megavar. Just for starters. Does that improve things or does that hinder things? Let's go back to PowerFlow, solve the equations. Right, we can still, with the switch open, we see that we still have 1.29 megavar supplied. With the switch closed, we've reduced that demand from the utility by the total 1 megavar MVA, and now that's literally within this particular bus, and it's being supplied during the operations by this capacitor. So in terms of just straight efficiency, we've reduced the loading on our whole system, and that may give us pause to see what the cost of implementing this type of power factor correction, albeit we may not have been, just for this one load, we may not necessarily have been paying a penalty for power factor. Now, everything I just went through, I suspect, is like falling off a log for most of the consulting engineers in the audience. it's stuff we learn in school. It's stuff we kind of aware of. The neat thing about the tools is that it becomes so obvious that that's what's going on. The conversation with my client now is not one of trying to sell him anything. It's like just explaining to him what his system's doing and what it's not doing, and helping him be able to prioritize where a recommendation such as this falls into his priority level. All right. Without going into much more than that, frankly, I encourage anyone that doesn't have EasyPower PowerFlow to download a demo and play with it, because there's, even if you have just an ARC Flash database, it becomes very obvious where things need to start in terms of being able to improve the model of the system to use for PowerFlow. Okay, I feel like I'm kind of starting to repeat myself, so I appreciate your patience. Let me kind of jump back into where I was on my presentation. May get a glitch out of this since Windows updated. It kind of scares me. Okay, everybody's back online. Got it. Okay, so what did we learn? As companies outsource the facility engineering function, I predict there will be large gaps between what a company needs and what's provided by a typical maintenance, and in fact, in some cases, what's provided as standard fare from engineering consulting firms. It's basically my observation that a company needs to be in deep water before they go out and start asking questions. And it's that lag in accessing resources that could be very costly. I believe successful firms will develop a method of proactively offering suggestions, advice, and methodologies for better interface, and frankly, by maintaining the system model with a maintenance mindset, there could be, we've documented cases where the reducing the ongoing system maintenance costs can actually be reduced. So even though we're observing a proliferation of system facility maintenance organizations, I think their checklist of services falls short of what's going to be required to truly augment facility engineering and most of the time it's that technical support that customers don't necessarily understand how to access. So it would appear to me that opportunities abound for engineering firms who are able to accommodate a more holistic approach to the technical needs of a client system. Thank you very much for attending. I appreciate everyone's time and attention. I invite you to access the EasyPower website. We have tool demos that are free for downloading. We have a number of how-to webinars pre-recorded. We have copious ARC Flash resources that are available free for download. We also have an event schedule for regional training coming up in the Dallas-Fort Worth area later this month. Here in Portland, starting on the 31st, there's going to be a class on harmonic and dynamic stability. And then for those of you that may be weary of winter, sometime after the holidays, we have the regional training scheduled for San Diego in early 2017. Thank you very much for attending, and I'll leave the line open a little bit for questions and look forward to talking to you down the road. So let me see what we got here. So often we perform, the question is, often we perform arc flash on DC systems. The question is how to do this and what's the standard that EasyPower is following. One of the nice things about the EasyPower tool suite is that the same short circuit and arc flash module can be used for AC, DC, and hybrid systems. And the in fact, we're going to be doing a guide on a DC arc flash within the next few weeks. The standard that we use or the methodology that we use is based upon NFPA 70E, and it's pretty straightforward and it's interesting. The results are actually very interesting because I've had these conversations with senior power systems engineers that we're expecting the system to operate a certain way, but until you see the operations of what the tool, visibility of the tool gives you, it's difficult to understand how the system is really operating. So yes, I encourage you to contact tech support at EasyPower or contact me, Jim, at easypower.com, and we can get into more detail. And a lot of this is covered with the Arc Flash resource book that's available for download on the resource page. So as a real example to compare load flow with Arc Flash database. You know, there's dozens of real examples, and the first thing, I guess I did a poor job of doing that. We have webinars on doing PowerFlow and load flow and utilizing specifically in analyzing power factor correction and motor starting circuits. Yeah, so I guess the answer is no, and I think that would be a good suggestion for me to come up with a direct comparison between an Arc Flash database and what results in terms of a realistic load flow database. So we'll get the word out on that when we have that comparison done. Should be able to do it within the next few weeks. Question is voltage and current to compare with the load flow. Well, okay, so the question, Bao, is saying how do you safely measure the voltage and current during an arc flash data collection? Frequently, it depends upon what is available in the system. Most often buses have a voltage reading. If we're doing data collection on hot buses, I can't tell you how many times I've crawled in behind a, the operative word is safely. Was well aware of arc flash, I routinely crawled in behind systems to be able to access bare connections to measure current and voltage, and so the challenge varies based upon your specific system, and again, this is where I would want to have an electrical engineer look at how best to facilitate voltage and current measurements. It may be that we need to install additional metering. Frequently, you can have remote metering that's available, and so I'm mostly referring to temporary or data logging connections. Right. Yeah, and the comment is that usually that's done, the arc flash data collection is done during de-energized, and if you don't have any other way, well, you connect up the equipment for measuring voltage and current while it's de-energized, and make the effort to take readings until you have the opportunity to de-energize it, to disconnect it. So where there's a will, there's a way. Talked about Arc Flash database as some kind of separate database. We actually have available on the website the process used for Arc Flash data collection. And the reason I refer to it as being less accurate than a refined model, or where we want to gravitate towards in developing a model for load flow, is that there's a certain number of estimates we need to make, especially in cable length and the like, because things, if we're not working on an as-built system or a newly built system, we're having to make a certain number of assumptions, and those are some of the points that we need to refine as we're developing the load flow database. So again, it's based upon our particular system and what we're trying to achieve, but no, it's not a difference in the library. It's a matter of scaling, for instance, motors and any other loads, even linear loads. So yes, email address is jim@easypower.com, and until you're asking if there's some way to calculate pressure relief ducts for switchgear rooms, that's not something I can address. I guess I would have to see specifics on the equipment we're talking about, and that doesn't necessarily, it may or may not impact a load flow calculation. So by all means, send me a note with more specifics what you're talking about. I'd love to get a reading on that. Thank you all for attending. As always, any EasyPower tool user, if you have questions or if you're trying to go through this process of refining your model, by all means access tech support at easypower.com for advice and counsel on how to improve your model. Look forward to talking to everyone down the road. Have a good day.